The components that will be discussed in today's video are the front outer case, the camera lens, the image sensor, the function button, the silicone push pad which is internal, and the button housing made of metal which is also internal.
This component is called the function button. It allows users to control the camera and adjust its settings. This particular button controls the magnification of the lens. We believe that this part was manufactured through injection molding, and several signs support this assumption that include injector pin marks, uniform wall thickness, gate and degating marks, and indications of a runner and sprue system. Compression molding, transfer molding, and blow molding could also be alternative methods of manufacturing. This component is the front mount cover of the camera. The front cover helps to protect certain components of the camera, including the circuit board, camera lens, and the battery holder. This is another component that we believe was manufactured using injection molding. Gate marks, ejector pins, uniform wall thickness, and abrasions from smoothing ejector pin marks indicate injection molding was used. Alternative ways to manufacture this component include compression molding, die casting, and investment casting.
The silicone pushpad is used to facilitate physical interaction between the user and the device. The user pushes a button which in turn depresses the silicone onto the circuit board and the device responds. We have assumed this pushpad to be made of silicone because of the clear rubber-like material that is often used within electrical devices. We speculate that the manufacturing process uses compression molding. The proof of concept is that the part is uniform wall thickness all around and the edges are uneven from a two-part mold pour. Some alternative processes that can be used to make this part are injection molding, liquid injection molding, and transfer molding, all of which can be used for making parts from elastomers like silicone. The next component we have is the button housing. The button housing helps support the button arrangement and gives it some structural integrity. This part is made of aluminum as it is not magnetic and relatively lightweight. The manufacturing process that we think was used to make this part is stamping. The evidence present is that the edge on one side is rounded. The side with the rounded edge is where the punch first made contact and created a shear plane. There are also vertical tooling marks around the perimeter of the part, which can be left behind by a die punching process. An alternative process to make this part would be die casting. Die casting would achieve similar dimensional accuracy and surface finish to stamping, however, extra time and money would be required to melt the metal. On top of that, the dies required for die casting are expensive and production times are long.
On the next slide here is the camera lens. The camera lens purpose is to focus light onto the image sensor. The camera lens is placed behind a small piece of glass treated with an anti-reflective coating, which is this image shown on the right. This is meant to increase the amount of transmitted light onto the image sensor. The camera lens, which is the image shown on the left, is a dome shape that acts as a focal lens, allowing light to direct towards the image sensor. To create this dome shaping, they use a glass molding technique in which a small piece of glass is heated, melted, and molded into shape, then cooled to solidify. Alternatively, glass casting, glass blowing, or optical glass could have been used. However, these manufacturing processes are usually meant for more detailed designs and at smaller quantities, resulting in a much more expensive product. And since we know that our digital camera is relatively inexpensive, we are confident that this technique was used. And the very last component to discuss is the image sensor. The image sensor is a semiconductor device that converts light into electrical signals, either by 1 pixel at a time using a CCD sensor charge coupled device, or by dozens of pixels simultaneously using a CMOS sensor, complementary metal oxide semiconductor. Our digital camera features a CMOS sensor and takes 8 steps to manufacture, 1 being the silicone wafer preparation, 2 wafer cleaning, 3 oxidization to act as an insulator, 4 photolithography, 5 etching, 6 implementation of the dopant ions onto the silicone substrate itself, 7 deposition of thin films such as polysilicon, and lastly the annealing process where the wafer undergoes a high temperature to activate the dopants and repair crystal damage. This particular sensor was chosen over a CCD sensor for many reasons, but primarily for its capability of faster readout speeds, which allows for continuous shooting and video recording at higher frame rates.
Thank you for watching our presentation. That concludes our video, and here are the references used.